So to start, just like with Twitter, we're going to do our functional requirements. So we're just going to copy a lot of this stuff down. And non-functional requirements. And then we'll get into a little bit of the implementation. And we won't take as long doing that. And hopefully we can dive into some code quickly. Okay. So I think the biggest thing is going to be, this is Uber. Let's just close this down for a little bit. So what does the app do? So there's going to be two parts. There's going to be the driver experience. And there's going to be the passenger experience. So a passenger needs to be able to request a ride. And we're not going to get into car sizes. We're not going to get into like Uber Luxury or Uber XL, things like that. Just base request a ride. We need to be able to cancel a ride. And then we need to know if, and then pay. We won't get too much into the way we pay. We're going to just assume you use some sort of service like Stripe, which is pretty common nowadays. And then what else? Maybe a during trip, view directions, and rate the driver after trip. Okay. Now the driver experience, you need to be able to add acceptance to a ride. You need to be enable taxi mode, start to accept rides in the area. You need to be able to message the, well, we won't do the messaging. We'll do that another time. So enable taxi mode and then disable taxi mode. You need to be able to, what else you need to do? Accept the passenger. And that's all we'll do for now. Okay. So non-functional requirements. So Uber is actually a really interesting one because at the beginning they were not well architected. They used an MVP of just a simple front end and a simple back end. And it actually led to them being basically overburdened. They couldn't handle all the people that wanted to use the app. The team had to find a new way to scale, and they actually went to a service-oriented architecture. So each different service has its own kind of side of the app. So let's get into a little bit what this looks like. So the non-functional requirements. This is a highly available app. This is a write-heavy system. Constantly, the geolocation of the cab is changing, right? Because they are getting ready to take the next ride once they are, in service, ready to go. Constantly geolocation is updating. Let's see, this is, maybe, let's see, what is Uber numbers daily? How many rides? Each driver, Uber revenue and statistics, sure. So 156 million people once a month. Uber drivers completed 11.27 billion trips. That's actually insane. Okay, so 11.27 billion divided by 365, that's 308 million, I believe. Let's see, 300,000 or 800,000, 30 million rides a day on average over a year. 30 million, that's actually crazy. 30 million rides a day. So, and these are going to be highly concentrated in cities. Okay, so we could start just diving into what this looks like. So just like the Twitter one, let's pop over here. So we're really going to have two, and it could be the same app, right? It could be the same code, but it's really going to be two clients. We're going to have the drivers, and on the other side, we're going to have the passengers. Passengers. So basically, for everything, we're going to have two different things. And you could think of this as like a simple supply and demand, where you would have the supply app, which is the drivers, right? They're supplying the taxis that are required. And then the demand is supplying the users for it. And then we'll need some back-end asynchronous architecture to connect the supply and the demand, right? Super simple. That's a super simple highlight over what it is. So, right, so we're gonna have this API service out here. This is the passenger API. Oh my gosh, I cannot spell passenger API. And we're gonna have the driver API. And these, these types of endpoints are going to be like start accepting rides. That's going to take in a geolocation. It's going to take in a time. And then there's going to be a stop. And then also going to be like a driver ID. Stop accepting rides. This is going to be also an accept next ride, where it's going to be a single ride ID. Well, it's going to create a ride ID by having a user ID, driver ID, and a geolocation to and from. So that's going to be accept the user ride. Stop accepting rides, same thing. It's just going to be a time and a driver ID. Just basically say, I was Ubering from here to here. And we can get more into that as it goes. This one is going to be simple as request a ride. So this is going to be a user ID, a to and from location. What else? That's really going to be it, honestly. And let's just make these boxes a little smaller. Not too much smaller, though. Make sure they're still good. Okay. So at the end of the day, there needs to be some sort of asynchronous event handling to be able to say, I am accepting this ride because I've received a notification that there is a ride in my area, right? So it could go out to n number of drivers, and then it's the first one that accepts it. I actually don't know how the driver side of Uber works in terms of if it's sent out to multiple drivers. But we can say it's sent out to multiple drivers, because if it has to be sent out to one, wait for their response, it's gonna be a slower system, right? So it's basically here's a list of currently active. So maybe we go with that for now. So we know there's already gonna be some sort of queue, some sort of data hub that is holding the driver queue or the ride queue. And what this ride queue is going to be holding is the idea that there is a requested ride. So request a ride basically enqueues a message here. This one is polling messages to the driver API. And I really don't like that it's doing that. And let's just go boom. Can I just do straight? Straight. Okay. So request a ride, enqueues it. Enqueues ride request on, let's see. I don't know. I'm trying to think of the best way to say this. Enqueues on the data hub. And because geolocation is going to become a integral piece, right? Just because a user is requesting a ride in New York doesn't mean the drivers in San Francisco ever need to know about that. So a really simple way to do that is to connect the regions like the geolocation IDs, and this is done by a Google service that's, you know, the sphere is basically separated into chunks, and each has an ID, and that ID becomes the sharding key. And the idea in a database, when you have a geo replicated sharded database, is that there is many databases, and they only are able to, they're partitioned in a table, and the basically all the information that has similar geo locations are going to be in the same area in the database. So when in San Francisco I need a ride, I don't look for data that's all over the place. I just look in the partition, and it which is faster just for me. It's not like I look at the whole database and then I filter down. It's I look specifically by partition key in the things around, right? If you need a larger area, it's going to take a longer time for things like cities. It's going to be a really small subset, right? There's going to be a lot of Uber drivers in New York City at one time, and also a lot of Uber requests. So you don't have to expand past the scope of the partition. It is all the exact same zone of like a 3-mile radius that has the same ID. So now your geo-replicated sharded database allows the lookups to be quick. So I have a demand. I put that into the ride queue. The ride queue asynchronously updates and writes the database. And the reason it does this asynchronously is because the process needs to be kicked off by events. So it's event based, right? So drivers get a notification or get a new item in the list or whatever it is by event, and not just like a, hey, every 5 seconds, let's ping, right? Instead, it's a push system where I'm waiting for an event and I push onto you. So this could be like a Kafka, like an Azure Data Bus, or Azure Service Bus, Azure Queue. AWS has a version of this, I'm sure. Just the name is escaping me. AWS Queue. What is it? Is it literally called AQS? SQS, Simple Queue Service, right? So it's a messaging queue. So super simple that way. Does that make sense? So now once we have the passenger say, I request a ride, then this event comes out and says, okay, what drivers do I need to look? So now we're going to get a little bit of asynchronous compute out here. Pop. And this could be part of the driver API, but really it's async compute. And on event, on insert, on ride request, right? So it logically makes sense. You're going to say, oh, what are the closest Uber requests in my area? And obviously, some of the app does this a little differently, where you are in the middle of requesting a ride, and then it says, here are your options. Now you can pick different things, and this one's this far away, and they have this rating. And the rating system is a whole different thing, right? Pretty simple scenario where a driver ID is connected to ratings of past rides. Not overly difficult to do. Right, that's just simple relational database stuff of you have ratings over here, and then you have drivers over here, and you just connect them up. Super simple. And then users are the ones creating the rating. So that's a super simple many to many, right? Where a driver can have many ratings, and a user can give many ratings back. So super simple that way. But the harder part is getting those ride histories to be created. So you have an on ride request. So a geo-replicated sharded database, you enqueue, there is a request to the ride queue, goes to the database, places the database. And this can be done, the API could also be putting in the database. You could also push it off to an asynchronous compute, same thing over here. But somehow from the queue gets placed in here. And really this is this is going to hold more data. The asynchronous compute is going to be from, this side of it, where it's, it fanned out. This is a fanned out thing. Scaled function in region. So, you know, you're going to have all over the place these different computes. Let me zoom in just a little bit, make sure this makes sense. So yeah, we're getting there where we have now basically each region kind of has its own infrastructure, right? Because each region is going to be self-contained. You're not going to ever want data from a driver in San Francisco in the New York kind of Uber ecosystem, if that makes sense. So let's go back here. And let's just start doing some API endpoints. And so we have a lot of them kind of already documented, right? So from the passenger perspective, a passenger API. Oh my gosh, I cannot spell passenger. We're gonna have like request a ride and all these things. And actually, I was realizing we're going pretty long on this. You know, when we first start out. So I'm just gonna pop this in there. And we are going to API diagram, and we'll continue on the Uber system design next time as we get further. But yeah, that's going to be a quick highlight over Uber and the way it's going to be connecting users to drivers, and it's all about supply and demand and how you match in the region the correct drivers to users. That on me, so we'll just go to that. Okay.